Here we have a SAT math problem. Okay, let's go to the question. In the figure above, the radius of the circle is 12. If the length of the chord AB is 18, what is the distance between the chord and diameter? Okay, here this line segment represents a diameter because it passes through the center of the circle, and this is a chord. And now we have to find the distance between the diameter and the chord we have here. Okay, the distance between the chord and diameter is given by the perpendicular line drawn from the center of the circle to the chord. Okay, now let me draw a perpendicular line. I have drawn a perpendicular line over here. Let me say this is point C. So this OC is a perpendicular line drawn from the center of the circle to the chord AB. So the length of this perpendicular line OC represents the distance between the diameter and the chord. So now mine is to get the length of this perpendicular line OC. Since this OC is perpendicular to AB, we have right angle over here. Okay, now let me draw a radius by joining the center of the circle O and the point B on the circle. This OB represents the radius of the circle, and it is given in the question, that is 12, the radius of the circle. So the length of this OB is 12. Okay, whenever I draw a perpendicular line from the center of the circle to a chord, so the perpendicular line will bisect the length of the chord. That is, this perpendicular line OC will bisect the length of the chord AB into two equal parts. Already we know that the length of the chord AB is 18. So this 18 will be divided into two equal parts. That is, this is 9 and this is 9. Okay, now let me consider the right triangle OBC over here. In this right triangle, OB is the hypotenuse because it's opposite to the right angle. Okay, now we can use Pythagorean theorem to get the length of this perpendicular line segment OC. That is, according to Pythagorean theorem, sum of the squares of two legs of a right triangle equals to square of the hypotenuse. That is OC square. This is one of the legs OC. I just squared the leg OC. Let me square the second leg, that is BC square. Okay, here I got the sum of the squares of two legs of this right triangle OBC. That must be equal to the square of the hypotenuse, and that is OB square. Okay, here we know that BC, the length of BC is 9 and the length of OB is 12. We can plug in 9 and 12 for BC and OB respectively. And we have to get the length of OC, which represents the distance between the chord AB and the diameter. Okay, we can write this OC square as it is, and for this BC we can plug in 9, that is 9 square, and for this OB we can plug in 12, that's a radius, 12 square. Then we have OC square, positive, the value of 9 square is 81 and the value of 12 square is 144. Okay, now let me subtract 81 from both sides. When I do so, this positive 81, 81 will cancel out. Then we get OC square equals to 144 negative 81 is 63. Okay, now let me take square root on both sides to get rid of this square. Okay, let me do it. Okay, here the square root and square root will cancel out. I'm getting OC on the left side. And usually when we take square root on both sides of an equation, for the square root over here, we consider positive or negative sign. But here OC represents the length of one of the sides of the triangle, so it can never be a negative value. So since always it is positive, we can consider only positive sign for this square root. So let me take this square root, positive square root. And now what we can do is we can decompose this 63 into its prime factors. That is, let me write 63. Okay, here 63 is divisible by 3. Okay, let me divide this 63 by the prime number 3. When I divide 63 by 3, I am getting 21. So 21 again, it's divisible by 3. So we can divide it by 3. Then I am getting 7. 7 is a prime number. Now we can stop it. So now for this 63, we can write 3 times 3 times as 7. So because when I multiply 3 and 3, I am getting 9. 9 times 7 is 63. So for 63, we can write 3 times 3 times 7. Okay, here OC equals to, for every two same numbers multiplied inside the square root, one number will come out. So for these two 3's, 1 3 can be taken out 3 times the square root of 7. Okay, now I got the length of this perpendicular line segment OC. That is 3 times square root of 7. So the distance between the chord and diameter is 3 times square root of 7. We find this 3 times square root of 7 in answer choice B. The correct answer choice for this question is B.